this assessment asks us to consider which term has broader application, the cis-trans or the EZ. To answer this question, consider the molecules shown. When we think about cis or trans, what we're really talking about is a relative location of substituents. So two substituents that are cis are on the same side, two substituents that are trans are on opposite sides. So when we look at a molecule like this, we could say that the bromine and the ethyl are cis to each other, but the ethyl and the other ethyl are trans to each other. This bromine and methyl are trans to each other. This methyl and ethyl are cis to each other. So if we were going to try to name this reaction or name this molecule using cis-trans, it could be confusing because what's cis or trans to what? The EZ, on the other hand, gives an absolute designation. It tells you that the higher priority substituent, in this case the bromine, and the ethyl on the other side, so this ethyl is 2, this ethyl is 1, this one is 2, it tells you that the two higher priority groups are on the same side of the alkene. This molecule would be Z, but for the purposes of this question, it shows us that the EZ has broader applicability. The EZ you'll always be able to name an alkene that exhibits stereoisomerism using EZ. You won't always be able to do that as clearly with cis-trans. We're in chapter 8 right now of making these videos, and my son, who's doing all of the editing, has insisted that I remind you to subscribe. I haven't done it yet. He's mad that we're 8 chapters in and I haven't. So subscribe to the videos. I hope that's how he wants me to ask. I'm sure he wants me to say it in a different way, like his other YouTubers that he follows, but subscribe, like the videos.